Now, if we talk about the maximum force, which will keep the body in equilibrium when it is at a point of sliding upwards. In this case, the frictional force F2 equal to nu R2 will act downwards as the body is at a point of sliding upwards according to the figure below. So we are saying we need a maximum force, P1. Okay, let us call it P2. And this is the reaction R2. We are saying in this case, we are having a body which is at an inclined plane with the angle alpha, and we need a force P2, which is a maximum force that will keep the body in equilibrium at a point when this body is just about to slide upwards. The other one was minimum because it was to prevent the body from sliding downwards when the body is about when this body is about to slide downwards. The minimum force required to keep it in equilibrium was P1, and we calculated that one, and that is the expression. But now we want to look at the maximum force that will keep the body in equilibrium at a point of sliding upwards. Upwards. We need to note that. So when it is at a point of moving upwards, then the frictional force is going to act along the inclined plane but facing vertically downwards. So the friction force will act along the plane downwards. Okay, if it is along the plane and moving downwards, we are going to resolve forces. Always on these problems of motion on an inclined plane, you resolve forces along the plane or parallel to the plane, then also perpendicular to the plane. That's where you can generate the equations that are going to help you. But you need to remember that this is W cos alpha, and a force that is moving parallel to the plane is going to be W sine alpha. So resolving forces vertically. Okay, let us resolve perpendicular. We resolve perpendicular to the plane. So when we resolve forces perpendicular to the plane, that's where we involve in R2 and then W cos alpha. So our R2 should be equal to W cos alpha. And we can call this equation 1. Then W, when we resolve forces, then resolve forces parallel to the plane or along the plane. What happens is that if it is along the plane, we will have P2 and P2 equivalent to F2 plus W sine alpha. So we'll have P2 equivalent to F2 plus W sine alpha. But this F2, F2 is the same as nu R2 according to the definition of friction. So the definition of friction or coefficient of friction. So P2 therefore will equal to nu R2, whereby R2 is here. So we'll have nu into R2, which is W cos alpha. Okay. W cos alpha times your new R2, which we have already put there, plus W sine alpha. So what does that mean? I already know what nu is. Nu is equal to tan phi and is equal to sine phi divided by cos phi. So P2 will equal to sine phi divided by cos phi, okay, into W cos alpha plus W sine alpha. But also, if I have sine into alpha plus phi, this is the same as sine alpha cos phi plus sine phi cos alpha. I want to get a relation, an expression here, so that I can summarize the whole of that expression into sine into alpha plus phi. So I can only do that if I multiply both sides here by cos phi. So I have my equation here, maybe equation 2. I am going to say multiply equation 2 by cos phi both sides. So if I multiply by cos phi both sides, I'll have P2 cos phi, which is equal to sine phi divided by cos phi, now times cos phi that we have introduced, times W cos alpha plus W sine alpha cos phi. So you can see that this and that will cancel out, so that I have my P2 cos phi equal to W is common, sine into alpha plus phi, because we said sine alpha plus phi is equal to sine alpha cos phi plus sine phi cos alpha, which is the same thing here. Sine phi cos alpha is here, plus W, plus we have a component of sine alpha cos phi. Sine alpha cos phi is here. So I just factorize out W and I remain with that expression. So for that matter, therefore, the maximum force P2 will equal to W sine into alpha plus phi divided by cos phi. So this is the maximum force required to keep the body in equilibrium just at the point of sliding upwards. So what you have to remember is that you have to resolve forces perpendicular to the plane, you resolve forces parallel to the plane, and then from there you try to make P2 the subject of the formula. But remember, you try to introduce a cos phi, so that when you multiply it in here, you get an expression that looks like an expansion of a compound angle of alpha plus phi using a sine ratio. So when you expand it, you get sine alpha cos phi plus sine phi cos alpha. And from there, you have to manipulate that P2 sine phi out of cos phi, W cos alpha plus W sine alpha by multiplying by cos phi both sides, and you get that expression, which now you can summarize as W sine into alpha plus phi. Then because I need the P2, I just divide both sides by cos phi. And that will be the maximum force required to keep the body in equilibrium when it is just at the point of sliding upwards.